Okay, so this will be the practical electricity. For practical electricity, we need to learn two more equation, which is the power and energy. So for power wise, power is actually I introduced this terminology in a bit of COE. So what is power? Power is the rate of energy supply. So let's just say if I introduce power and energy, so power is equal to energy divided by time, because every time you see rate, right, is something divided by time. So in this case, it's the energy that is divided by time. Okay, so what about the power in terms of Vi and R? So we have this equation called P equal to Vi, first of all, and of course the second is your I square R. The third will be your V square over R. Okay, so how do I change from the first equation to the second equation, or the first equation to the third equation? This is actually we need to combine both your R equal to V over I and P equal to Vi. So let me just derive this for you. Okay, so if let's just say I have a P equal to Vi, I want to convert Vi in terms of I square R. So how do I do that? So I square R. So first thing, we need to recall back our R equal to V over I. So R equal to V over I. Of course, I make V the subject, which is Ri. So V equal to Ri, right? You just sub inside here. Because here, right, Ri, so sub Ri into V. So you will see that, my P is equal to Ri times I, which is equal to I square R. Okay. Of course, how do I change P equal to Vi to in terms of V square over R? Okay, so this one also I can use R equal to V over I, but now I must make I the subject. So R equal to V over I. So I is equal to V over R. So now you can see that my I and I is here, right? So you just sub V over R into this part. So you will see that P is equal to V multiplied by V over R. So it's equal to V square over R. So that's how we combine, that's how we derive the second and third form for the power wise. Okay, but of course you don't need to derive, just memorize by heart. Okay, so the next thing is power. Power is in terms of watts. Okay, of course, VIR is something that we know already. So sometimes O level might ask, what is meant by 24 watts? So you need to know that 24 watts is just 24 joules of energy supplied to the electrical appliance in 1 second. Okay, so this is the meaning of 24 watts. Okay, so let us see this example and know how to use our equation. So what is the power dissipated by resistor R? So power dissipated by resistor R is 12 multiplied by 1.5. So as long as you are given I and V, right, you just use the very first equation, P equal to VI. So V is 12, I is 1.5. So you will get roughly 18 watts. Okay, so, 18 watts. Okay, so 18 watts means 18 joules of energy is supplied to the resistor in 1 second. Okay, let's move on to example 2. Okay, example 2, you can see that is a bit different now. So I have a 10 ohm resistor and I'm given the voltage, right, 8 volts or potential difference. Okay, we are not given the current, so how should I do this? Okay, so of course I must use another form of the power formula. So V square over R. So V square is what? V square is 8 square. R is 10. So 64 divided by 10 is roughly 6.4 watts. Okay, so let's take a look at example 3 now. Okay, example 3, what is the power dissipated in the 15 ohm resistor? So notice this is another form, right? Because you notice that there's only resistance and current. So what should I do? So P is equal to I square R. So I square is what? 2 square, R is 15. So 4 times 15 is 60 watts. So that is the 3 example of how should we use our formula.